Okay, let's look at the homework 1.8, problem number 8. Right, so we have this piecewise defined function, and you can see that each piece, this is a rational function, but x is less than 2, so it's all in the domain, so this by itself is continuous. And the second formula is a quadratic function, so it's a polynomial of degree 2. It's continuous everywhere. And the last one is a linear function, so it's continuous everywhere. So there's no problem by themselves, but we have to make sure that this is continuous at the gap. So gap would be x equals 2 and also x equals 3. All right, so let's look at that. All right, so we need to make sure that actually a limit agrees from the right and left. So I'm going to just take the limit of this function f of x as x approaches 2 from the left, and also compare that with the limit of f of x as x approaches 2 from the right. Alright, so if it's approaching from the left, so it's x is less than 2, so we have to use the first formula. So you have a limit as x approaches 2 from the left, and we have to use the first formula, so x squared minus 4 all over x minus 2, right? And we know that we can factor out the numerator, so let's go ahead and do that. So x approaches 2 from the left, so we can factor this guy out as x minus 2 and x plus 2, and all over x minus 2, right? So we can cancel x minus 2 on top and x minus 2 on the bottom. Then we can just plug in, and you can see that this is going to give you 2 plus 2, so it's 4, right? But if you are coming from the right, then you're going to have to use actually the middle formula, right? So we have a limit as x approaches 2 from the right of this quadratic function, ax squared minus bx plus 3, right? So since it's a polynomial function, we can just plug in a number. So plug in 2, 2 squared is 4, so you have a 4a, and you have minus 2b plus 3, right? So this is the right-hand limit at x equals 2, and in order to be continuous, these two limits have to agree with each other, right? So we have this equation. So we're going to get, so these two combined together, right? We have this condition. So you have a 4a minus 2b plus 3 must be equal to 4, right? In order to be continuous, limit has to exist there. All right, so we got one equation involving a and b, and we're going to look at the x equals 3. So we take the limit as x approaches 3 from the left, and we look at the limit of f of x as x approaches 3 from the right, all right? Alright, so coming from the left, this one, we still have to use the middle formula. So you have limit as x approaches 3 from the left of the quadratic function ax squared minus bx plus 3. So it's a polynomial function, you can just plug in. So 3 squared would be 9a, and minus 3b, and plus 3, right? And if you look at the right-hand limit, so it's a limit as x approaches 3 from the right, and here we have to use the last formula, so it's going to be 4x minus a plus b, right? and this is going to be equal to, right? You can just plug in, so it's going to be 4 times 3, so 12, minus A plus B, right? From here, we have this equation, so we have to make sure that the 9A minus 3B plus 3 must be equal to 12 minus A plus B. Alright, so we're going to try to simplify as much as possible. Here, I'm going to probably subtract 3 from both sides at least. So you're going to have, so subtract 3. So you have 4A minus 2B is equal to 1, right? And maybe I'm going to put A on this side and B on this side, so we can just add A and subtract B, right? So that will give us 10A and subtract B, so negative 4B. Well, actually, I'm going to subtract 3 as well, so put it over here. So 12 minus 3 would be 9. Right, so we have that. So somehow we have to, solve for A and B. What we can do is I'm going to actually multiply this guy by 2. Then I'm going to write it here. So if you multiply this by 2, so you're going to get the 8A and minus 4B is equal to 1 times 2 is 2. Right, so this way I can do a subtraction. Right, 10A minus 8A is 2A. And a negative 4B minus negative 4B cancel out. And a 9 minus 2 would be 7. So by dividing through by 2, A is going to be equal to 7 halves. Alright, so once you know that the A is 7 halves, we can probably use maybe this equation right here. So if you plug in 7 halves here, so 4 times 7 is 28. Or actually, how about this? I'm gonna erase this. Alright, so we have, let's see, 4 times 7 halves would be 14. Minus 2b equals 1. Right, so subtract 14 from both sides. We get the negative 2b is equal to negative 13. Right, then you can just simply divide through by negative 2 to isolate b. So b is going to be negative cancel out, so 13 halves. Alright, so let's plug it in. So A is 7 halves and the B is 13 halves. Alright, A is 7 halves and the B is 13 halves. Right, so let's check by submit for testing. Alright, it came back and looks like we got the A value and the B value correctly. Alright, that's it. I hope that this was clear.